on this computer. All right, again, thank you very much to show up in this session. I'll try to use it as much as we can. It's really very important to see you guys here today. Again, I think we can rely on this in the future. I have a good news. Today, successfully, I managed to finish the Tahiyya course. Do you remember when I used to leave, trying to push myself to leave early because I had a course from 4 to 6 every Monday? Successfully, today I presented my Mihi and I participated in the quiz, in the assessment. We had about 4 assessments to do. So finally, I did, and I passed this course. Very, very good. I'm very happy about it as well. I'm proud. So that's something really good. Now, today I will start with questions related to your topic of the test, which is very important because I will start covering topics from where we started at the beginning, and then we can continue with the topic itself. So this is a question. I'll try to answer as much as I can today. So we start with this kind of questions. In the test, you may get questions similar to this one, which is this type of questions. Remember, it covers the topic concurrent and non-concurrent forces. And that's why I want to present it for you guys and show you how it works, how can we solve it. And again, yes, thank guys for the congratulations. It's very good. I recommend you to take this course. It's really good. It's really good. If you're keen to settle down in New Zealand and you want to learn a lot about Maori culture, I really recommend that course. And maybe one day after the test, I will talk about it. It's really good. All right, so this question 1, determine the horizontal and vertical components of a reaction at the pin A and the reaction on the beam at C. So if we just adjust this one so it can look really better. So very basic question. If you see here at point A, we have 2 support reactions. And at point D, again, we have 2 support reactions because A and B are hinged. And at point C is kind of giving me 1 support in towards DC. We can call it FC, for example. And at the free end, at point B, there is a 4 kilonewtons force applied in that direction, downwards, trying to push this orange beam, if we can call it a beam. So from this question, if we just revise it and we highlight. So what I want you really, guys, every time you try to solve these kind of questions, even if you are in the test or exam, first of all, read the question itself and say exactly what you want to find. Horizontal, this is, I will highlight it. We want to find the horizontal and vertical components. Okay, I need to be very specific. Of reactions, reaction, good. So we are adding information. At a pin A and the reaction on the beam at C. So it's very, very clear this question wants me to work A to C and B because B part of it. So now, basically what we have learned in the past, since the last 5 weeks studying mechanics, we start always with what we call it free body diagram. So step 1 always is free body diagram. Now, free body diagram, always we try to consider it something related to the area we are interested to study. So in this example, the area we're trying to study is highlighted in orange. So I'll bring this orange bar and I'll put it here and I'll try to allocate the forces on it. So I'm kind of just copy pasting the information so it will be easy. For you guys in your tests, you need to redraw again, resketch the diagram again or the free body diagram, all right? And here is the things what we want to see. So what I want to see in the direction of DC should be a force going in that way, all right? And to be more precise, it should be in the center because remember, this is 1.5 and 1.5 meters. I can this is another things about using PowerPoint as well, will help you in the future. How can you improve the PowerPoint and make as much as use of it? This force, let's call it FC. Why? Because this is where is located the force or the point C. So I put the point C here. I bring my dimensions to save me time. So this is the 1.5 meters, and this one is the other 1.5 meters, which is distinguished for me the distance for C with respect to C. All right. Now, at point A, what do I have at point A? What we learned in the past, or we're doing it a lot, that's point A. It's always, since it's hinged, and I don't really know what's one of the questions you may ask, hey, how do I know if this hinge it's active in the X or the Y axis, horizontal or vertical? So technically, I would say, hey, guys, I don't know at this stage. So the best way is to draw both, and then we can decide which one will give me the right answer. And if I find one of them will get me 0, that's mean something is wrong. All right. So I will need to name them to make sure that I'm using the right information. Some guys, they are asking about the link. I'll try to get them very soon. So for example, I will finish the support reaction. So we call this one F, or this one AY, and the other one will be calling it AX. Now, a question you come to you and you ask, hey, why did you put that in that direction? Usually I'm putting the AY upwards because logically, the 4 kilonewtons trying to push the beam downwards. Therefore, what I need to do, I need to support it by AY. Even there is a force FC is going in that direction, which I need to understand. Now, since I know that all this information, now I need to put something is missing in this diagram. If you look carefully, what's missing in this diagram is the angle where FC is acting on the beam. So this angle, if just you look to the dimensions very clearly, what do you have? You have this triangular ACD, 1.5, 1.5. Technically, a triangular with two lengths are equal. Therefore, the angle here is 45, and this one is 45, and this angle should be 90 degrees. Very basic trigonometries. Therefore, I can put here the angle is 45. All right? And then 45 degrees. I'll make sure to use, sorry, put it in the wrong direction. Insert. This is a good day as well to learn as well how to use the equation editors, because in the future you need them when you write your reports. All right, so this is the angle is 45 degrees. So after finishing all of that, that means step 1 is done. I have sketched my free body diagram, illustrated all the important information I need to see. And to make sure, I need to check again, just for security, like make sure I haven't missed anything. So this is force C or FC going in that direction, 45 degrees. This is support reaction AX. I assume it like that way. I don't know yet which direction should be going. And this is AY. And there is a 4 kilonewtons at that end, but there's nothing, no support reaction there. Now you ask me, hey, why you ignored the support reaction at D? Remember, in the question, he wants us only to find the horizontal and vertical components of reaction at pin A and the reaction on the beam at C. So that's the reaction at C, and this is the support reaction. Therefore, I don't need to bother myself with D. But if I found there are information needed from D to help me to find AX and AY and FC, yes, I will go and try to find the information. So since, guys, what I want you to do, try to solve, I will give you maybe 2 minutes to solve algebraic summation of forces in the horizontal direction and vertical direction, and write the equation so I can write it together with you guys. Because I need to send the email for a couple guys, which I think they couldn't manage to access yet. So I will send them this very now. All right, another student. If you're having audio issues, it's really if you can follow the typing at the moment, or you can restart the computer or something. Yes, I want you guys to find at the point A, AX and AY. I call it now AX and AY, or you can call it FX and FY. It's up to you. Yeah, that's, I think, if you have issues with your audio, I think the main the reason is your network. It's how is your Wi-Fi. But anyway, don't worry. This lecture is recorded, and as soon as finish, will be posted on YouTube, and you can watch it anytime, so you don't have any issues. And that's why it's the possibility. The other option is you can watch what I'm doing at the moment. All right, so let's start. Now, I look carefully to this diagram. Now, there is always, I will tell you this secret, always there is a shortcut to solve these kind of questions and a long process. Both of them doesn't matter, but one of them will help you to avoid simultaneous equation. Now you say, wow, I like this term, it's very cool. How can I work on that? And maybe I don't like simultaneous equations, that's why you need to pay attention now to these things, what I'm saying. Look to the information. If you take a point or a look at point A, look at point C, look at point B. At A, you have two unknowns, AX and AY. At C, you have FC, so one unknown. And at B, you have one known, 4 kilonewtons. So it's wisely to take a moment about point A. See, here is where I start to think outside the box. So why? Because when I take the moment about point A, it means AX and AY, they will be multiplied by 0 distance. So the moment will cancel these forces at the moment for that equation. But will be one unknown, which is the FC, and I need to find the components of it. And then the other one is the 4 kilonewtons. So let's start working on that. This is something, again, by experience you will learn it. It's try and error, and then you find, oh, this way will help me always to go to the easiest and fastest way, and you look into it. I always recommend, guys, you look to the information as much as you can, and then you can work with it. So here is M. We're taking it around point A is equal to 0. Now, I always got a question why I'm always choosing it clockwise, which is very interesting. I always choose it just randomly, to be honest with you. But since I have been asked why, then I was thinking, okay, let's choose today something different. What about that? So we choose counterclockwise to try something different. So that's the positive moment. All right. Now, just let this one here to show you the equation. Let's put this here so I can have a space. Just arranging my space here. All right, let's start with the first one. So is it clockwise, I assume it? No, it's counterclockwise. It's positive. So technically, 4 kilonewtons is going which direction? Is going clockwise. Therefore, what I do here, it will be minus 4 because it's going negative. Now, I need to show the FC, how it works. FC, to do it, is very easy to write the analysis for it. So this one is the first component for it, or the component for the FC. So one is horizontal, one is vertical. But they should act at that point, to be honest with you, to be more precise, because we want to take the right distance. So this one will represent for me, and kind of this is the action point for that force. So if this is the force where it's acting, I'm just showing you how it looks like in real, and then you can work on it. So let's maximize the size of the arrows so you don't confuse them with other drawings. All right, so this is the point C, this is FC, and it was here the angle, so by replacement will be changed to this point. So what you have, write the components for it. You have horizontal, which is FC cosine 45. But remember, because we're taking a moment about A, so this force will not be taken into account because it will pass through the point A. Now I'll take the vertical components for this force. I would type the equation here, Fc cosine, sorry, sine 45. By the way, even if you try cosine 45, will give you the same answer. You can try it. This is only works with 45 degrees because they are equal. It kind of like the angle is divided to half. Therefore, they have the same value, but don't do it with other angles because we'll give you wrong answer. So that's Fc sine 45. If you look carefully to it, will rotate counterclockwise. Therefore, will be plus Fc sine 45 degrees equals to what? To 0. Now, one thing I missed here. These all are forces times I need to put the distance. So what's the distance? 4 times 3 meters. This is the distance. So 4 times 3 meters to here. Now the other one, I need to add the distance. What's the distance? If you look carefully, it's acting from here, the middle point, till point A, which is 1.5 meters. 1.5 meters. And then you have your full equation. So always is force times distance plus force, because the force needed the components of it, times the distance 1.5. Now this equation has one unknown. Rearranging the equation, what you will end up, Fc value should be equals to 11.31 kilonewtons. Please try it now and check the answer. Perfect. Some of you got it. Good, good, perfect, perfect. That's a great job. Now, what I want you to do, guys, I'll give you again a time because I want you to work out on it to give you time. Try to determine now the values of AX and the values of AY. So since we have some difficulties in the voice, I may say now find AX and AY. I'll give you time. You have, let's say, 1 minute for each. Okay, in total 2 minutes. So try to find, you can start either with summation of forces in the horizontal direction or summation of forces in the vertical direction, and then let's see how can you find the right answer. And please remember, this is forces, so you don't need to multiply it by distance. Only when multiply by distance when it involves a moment. Good, we have 19 participants today. So let's see who join us. So Zain is here. I'll try to, while you're doing this, I'll try to fill the attendance. Zain is here. And remember, this this lecture is recorded now, so it will be available for you guys later. Cool. At the end of the session, I'll try to call your names, guys, so at least we'll see if you are available. All right, so okay, I start getting answers for a couple of the students. So basically, I got the answer, the first one from Darren. Darren, your answer for AY, it looks good for me. Yeah. Sagar, yes, your answer looks good for me as well. So you guys started with A now. No, that's AY, yes, AY. No, I think some of you getting a number slightly. Yes, so AX should be. You mean AX? We'll try it together. Okay, hold on. Let's do it together. Some of you start getting different answers now. I start feeling there are different answers. So let's solve it together, and then we see how can we do it. Perfect. So we start again with another space here, summation of forces in, again, it's up to you which one you start with. So I will start, for example, if I look to this, I will start with horizontal, because horizontal is a smaller equation, it's only one. So I will call it, yeah, FH is equal to 0. And the direction of it going, I would say, in that way, we assume it is positive. So if going in that way is positive, all right? So let's try this one. Okay. Now, what do we have? Based on that assumption, AX plus FC cosine 45. It's logically is wrong. Why? Because I can see AX cannot be in at the same direction of FC cosine 45, because this means AX is not technically supporting my force, because it's indicating that is going in the wrong direction. Therefore, I need to see why I'm getting it wrong, and that's how we can solve it, equals to 0. Then if I solve this answer, will be AX is equal to what? Will be minus FC. What's the value of FC? If you remember, we got it 11.31 kilonewtons cosine 45 degrees. And if you find the answer for this, AX will be equals to, AX equals to negative 8 kilonewtons. And that's mean the assumption I assumed it's completely was not right. It's supposed to go on the other direction. And that's logically should be opposite to this FC cosine 45. So that's what I'm trying to show you guys here. Even if I'm assuming it's wrong, the solution should help me to correct my answer. And that's how it works in this type of applications. Now, this is the answer for X. See what we managed to determine. First, we found the reaction on the beam at C, and now we found the horizontal reaction at A. Now I want to find the vertical reaction at B. Let's see if something, some of you trying to get AX 4. I think, guys, you need to try it again and see work it out on these equations. I don't think AX is 4 kilonewtons. Anyway, let's continue to find, and then we discuss it together. Summation of forces. I will just copy this one, so at least we'll save my time. And I will call this one vertical. Summation of forces in the vertical direction equals to 0. And to make it easy for me, any forces going upwards is the positive force. And forces in that direction, I need to determine which one. So what do we have? We have AY is going upwards. I just did assume that, but I don't know. Possibly I'm wrong. I'm just looking to my answers. So AY, it's going upwards plus, what do we have? FC sine 45. So this force is going upwards, this force is going upwards, minus 4 kilonewtons equals to 0. Now remember, what we have here, if we rearrange this equation, AY equals to what? Minus 11.31 sine 45. Now you say, why is minus? Because I moved the FC sine 45 to the other side of the equation, and plus 4 kilonewtons. We'll just push this to the second line so it doesn't confuse anyone. And this will lead you to an answer. Can you guess what's the answer for AY, please? What I'm getting here? Surprise, surprise. The answer for AY, it's around, in my case, I got it negative 4 kilonewtons. Now, what does mean that to me? that I also assume the direction for the AY wrong, but doesn't matter because the solutions start correcting me to get it to the right answer? Yes. So many of you try to, they're sending me the right answer, which is really, really good. And that's really awesome to see that level. So technically, when you solve this kind of questions, don't be afraid that you assumed wrongly the direction of your support reaction. They are going in different ways. Don't be afraid of that, because we have a solid information here, which is the 4 kilonewtons, the only one I put it in black so to show you that this force is going downwards, and the rest is all by assumptions based on the structure, how the geometry works. And even if I assume that in that way, then that's how it works. But see, I don't need to go back and correct it. It's just I say, then here I say, then AX should be in that direction. Because we are engineers, we don't want to really write a lot of discussion. So AX is acting in that direction. Very simple, very basic explanation. And AY, then AY should act in that direction. So it should be going downwards. And that's very easy. Again, we don't want to make it really difficult story, and you don't need to go and fix your free body diagram. Don't screw your free body diagram. Please leave it. I want to see, if you assume different angles, I want to see that's negative number, because it represents that your solution is correct, and you just need to acknowledge that the direction it should be going in the opposite direction, and that's all. Or you just write this should be going on the opposite direction. So it's not really something. I have a questions now here saying, can I say that 8 kilonewtons tensile for AX? Technically, if it's tensile, yes, you can say that, because as we say, if the force, the arrow is leaving the point, so it's tension. If it's going towards the point, it's compression. Yes, you can do that. That's also acceptable. That's what we learn, and that's what we have been doing since we started this course. So again, for the guys joining us, because now we have a couple guys join us now. So let's see. So I have Ellen, and try to get as much as we can. We'll give you guys time to write the answer and try it while I'm looking for the guys. So Ellen is here, and who else? Please, if I haven't take someone has his login as iPhone, I really appreciate if you put your name so I can take your attendance, please. Someone left. I think the person with iPhone left, so hopefully come back with a name. So if I call your name, please tell me you're here. Is Caleb here? So if you just type on the chat. For this question, yes. The one of the four, like the one in the y direction, is very difficult to say if it's both of them. They are tensile. You know, when you can say tensile, Thais, is when you really find the support reaction for it, or what we call it. So if you find the force in that direction, it will help us a lot to find. So for example, I'll tell you this. What we found, this is the force, right? But in reality, you should really find the force which is the resultant, which is supposed to be going in that direction. That's what you really need to find. Yes, it is. It is tensile force. It's correct what you're saying. But the tensile will be applied on the resultant force. So you find the resultant force and then you put in this one. So let me just take the attendance for the guys. So is Ibrahim here? Just type for me, please. And Asim, Caleb, Wesley, Ranjit here. Yes, I got your message, Ranjit. Thank you. And Ronil, is Ronil, because he sent me an email. I haven't seen him yet. Please, if I'm calling your name, it's easier for me if you just send me private message so I can see it on the text or the messaging. And Oliver, I haven't seen Oliver yet. All right. So we'll continue what we were doing in this session. Okay. Now, let's go back to the topic itself. Now, you may ask a question is like about the test. Let's talk real business. In the test, definitely you will get some questions related to the concurrent and non-concurrent forces. Definitely will not be this shape. Definitely will be a bit slightly more complicated than this shape, but the same principles. What you need to do, first of things, read the question very well, highlight the information the question wants you to find, and then sketch step 1 free body diagram. Step 2, here is the tricky point. Either you say, hey, this is a straightforward. So for example, if you started finding the summation of forces in the horizontal direction first, this will really make it very difficult because you will end up with AX and FC unknown. And then you need to find the moment to solve the equation. But if you started with the moment, and the reason I started with the moment, because I see at point A, I have 2 unknowns. At point C, I have 1 unknown, but I did write the components of it. And at B, I have 1 known, which is solid information, is 4 kilonewtons going downwards. Therefore, if I take the moment around point A, definitely I can find the value of AC with respect to that moment. Now, FC cosine 45 will be 0 because it's passing through the point A, the action of the line of the force. Therefore, the only force will be taken into account is FC sine 45 times the distance 1.5 meters. And also the 4 kilonewtons times 3 meters, which is the total length of the beam, one end to the other end. And that's equation here we start with. It's the helpful equation to find the value for FC. As soon as you find FC, then you can use the algebraic summation forces horizontal and vertical, rearranging. Don't be afraid, please, in the test. If you get a negative answer, don't go and correct your diagram. Just put an arrow like this next to say, or just say, then AX acts opposite direction. I don't want you really to write a lot of things about it because I don't want you to have a very messy free body diagram, very difficult to read. All right. Okay. I didn't get that. I forgot free body diagram of this triangle. Sorry. If you can send me by email. If you have something, maybe you send it by email. Yes. Since C at point C, I have only 1 unknown. It's better to really take it out point A. Okay. Do we start? Let's go and find another question related to this topic so we can see how can we solve it. So 1 second, let me try to choose something for you guys. Yeah, I think I have a very interesting question about this topic. Okay, I found this one is so cool. Okay, this question is actually related to 2 topics. So one is the beams and shear forces, and the other one is related to bending moment. So I will sketch the question for you very fast. It will not take long time, and then we can discuss it together. So insert, and you will have a beam, and that beam, it's supported at A with the hinge. So this is the hinge at A, and then supported with the roller at point B. So we call the first one A, and the second one is B. Now, interesting thing, what's happened in this beam? Very, very interesting. On top of that beam, from that end, you will have about till here, till the center, something is different. Let's call it UDL. UDL equals to 9 kilonewtons per meters. Okay? Interesting. And there is also a load about this point, which has the value. Let me just make this load looks very obvious. This load is, let's give a value, is 12 kilonewtons. Now, this question, if I pass it to you guys like this, will be invalid because you don't have dimensions. So from here, and then from here to there is another dimension. From here to this point is another dimension. All of these dimensions are 1.5 meter. So I will type 1.5 meters. So now you can start, but first I need to tell you what exactly I want from you guys so you can start on this question. So the question will be asking you, I'll type it for the guys who can't hear me very well. Determine the normal force which we call it shear force, and moment at point C. That's a very good one. Okay, so if you can try. I can't hear. So you guys, you don't need to have your camera. If you can switch off your camera, will be really very helpful. All right. Now, the question is, where do you think it's point C? This is a very, very good question. Point C, to help you guys, I will locate it for you in a second. Point C, I will say it's around this point. Let me make it in this way, and I'll put something next to it so you can see where is point C. This is point C. So it's about 1.5 meters from point B. So this is point C. So determine the normal force, shear force, and moment at point C. This is a very good question. The reason I want you to do this question, guys, is related to first understanding how can we deal with finding the values for support reactions, so concurrent and non-concurrent forces. And the second task is actually shear force and bending moment diagram. So it's a question related to two applications, which as normally we learned in this course. So I will give you maybe about, let's say, maybe 2 minutes, one for free body diagram, the other minutes maybe to find support reactions at point A and point B. And I'll try to find the guys who attended. So please, if Ibrahim is here, can you send me a text on the chat? Is Asim here? you're here, please send me a chat, a message on the group chat or privately. Wesley is here. Is Ronil? Did Ronil manage to join the class? I can't find Ronil. And Oliver. So at the moment we have 21 participants. It's mean 20 students out of 26 because myself is the number like first one. So 21 minus 1, that's 20. So we're missing 6 guys in this session. So let's me 1, 2, 3, 4, 5. All right, that's time. Let's start solving this question together. Diran is present. Yeah, I know. I was calling the other student. All right. Now, how can we solve this question? First of all, as we say, we start with free body diagram. So can you tell me, or I will help you, this it will be easier. The first thing I will start is to take a moment around the point I prefer. So let's say I will be taking the moment around point A. So insert and then equation, algebraic summation of moments about A is equal to 0. Should be capital A. Now, since we work with that moment, what we need to do is to decide which direction. Again, I would choose counterclockwise since I've been asked why I choose always clockwise, and that's why we'll learn another method. So this is my positive moment direction. All right. If you can please mute your microphone, will be awesome. So now, if we try to solve this equation, we start first with what? We need to do the free body diagram. So I'll sketch the free body diagram at that point. So here, I'll have a force going in that direction. I will highlight it so you can see it very clearly. And I will change the color for it. So you can see, let's choose, for example, red. Hey guys, if you can mute your voice. Hello, if you can mute your voice, will be awesome. All right, and then now the other one, it's going in that direction. So I will also try to make it looks different color. And let's choose it to be that color. So these are the common forces. Now, definitely, if I have any force in the horizontal direction, I will add that force. So I'll call the first one A. The second one, we can call it B, based on what we have here. And then I'll try to sketch these forces. Free body diagram is very easy. Remember, there is also a force resulted from the UDL, which should be going in that direction, exactly at the center line. And that force should be the value which I will write very soon. So let's give a color for it, keep it in that color so we can see exactly how it looks like. So now we can find the value for this will be 9 times what? All of that distance is 1.5 times 1.5. So 9 times 3. That's the value for that UDL. I don't need to find the answer now. I'll just keep it like this because I'll use all this product together. Now, we come to write our moment equation. So what do I have? The we're taking a moment around point A, therefore, this B force will be going in which direction? Will be positive. So I'll write B. By the way, you can write FB or B, it's up to you. Doesn't matter. The names are just names. The most important is the value. And they should be illustrated very clearly on the diagram. So that B force is going counterclockwise with a distance of what? 1.5 plus 1.5 plus 1.5 plus 1.5, so times 6 meters. That's the total distance. Plus or minus, we can see. The UDL, which direction is going negatively? So minus 9 times 3. This is only by itself is force. Now I need to bring the distance. So it would be the distance from this point to this point, and minus because it's clockwise. So it would be times 4.5. All right. Now what do I have? I have the 12 kilonewtons. Also, the 12 kilonewtons will rotate the beam clockwise. Therefore, is negative 12 times the distance from 12 to A is 1.5 meters. Rearranging this equation, what you will end up with, you end up with the value of B force is equal to 23.25 kilonewtons. All right? So by this, we determine the force at point B. Now we need algebraic summation of forces in the y direction to determine the other force. Now you say, what about the x direction? I'll talk about it very soon. Don't worry. Summation of forces in the vertical direction is equal 0. What do we have? Anything is going upwards, it's positive. This is my assumption, and I prefer it. So we write the equation very clearly, and we see how many forces going upwards and how many forces will be going downwards, and based on it, we can determine the values. All right, we start with the first force. What do you have? You have the force which we just found, B, which is 23.25, plus force A going upwards, equals to what? So kind of I'm writing summation of forces going upwards equal to summation forces going downwards. And that will be 12 plus, again, the product's 9 times 3. Why I'm putting the 9 times 3? Because I want you to see, guys, 9 is the UDL, is 9 kilonewtons per meters, times 3 because it's covering about 3 meters, and I take it always at the center. Now, again, you rearrange this equation. What you will end up with to find the support reaction at point A. A is equals to 15.75 kilonewtons. Now this force, what's the good things about it? I don't need to determine the force in the x direction. So if I come again with another equation and I say summation of forces in the horizontal is equal to 0, and if you look, that AX is the only force available, but I don't need to write it down because there are no forces. So no forces in edge direction, horizontal direction, because simply the body, there is no force inclined or anything indicating that. So technically what I used to save my time, I just converted the support reactions, the hinge and the roller, to support reaction forces. And I multiply the UDL value times the distance. And then I use the moment about point A, and then summation forces in vertical direction. This will help me to find the forces or the values for A and B. Now, is that all the question, or what's exactly he wants to find? He wants us to find, again, if we read the question very carefully, determine the normal force, shear force, and moment at point C. So technically, here is very, very interesting thing. What we do here. Here is the things which we'll try to avoid. What we're doing here. We will cut, okay, I'll start getting response. A is a hinge, why don't we have any force at AX? Because simply, since there is no another support reaction, we don't write it at this stage. So that's why I say forces of horizontal. I mean, you can still write it. I mean, there is no effect to put it here, but technically that's force. There is no magnitude of force opposite to it to try to prevent it. Therefore, writing it or is not writing it is kind of the same. It doesn't really change the results for you guys. So that's why you can still show it up, but it's really will not change anything to you because it's not valid. It's not working at this stage in this question. So you can still show it up, or you can say FH, no forces in the H direction. So when I write or I say there is no force, it's mean indication there is no force in that direction. All right. Now, to answer the question itself, this is very, very interesting. I need to cut the object. So what do I do at point C? I will do the cut around here, just here. And that cut, let's use this thing to looks like. So kind of what I did a cut to only everything involved from A to point C. Now you say, hey, I can't see point C, nor I, so I will take it out. Control V. Oh, no worries. And point C, so we can type here, it should be C. So C should be at that point. So technically, I cut the geometry and I put at point C. Now, what I need to replace at point C, please pay attention. This force, it should go. It's not anymore active because now I reduce my UDL size. It used to be 3 meters, now is 1.5 meters because I cut that geometry. It's an imaginary cut, okay? We don't cut it in real, but we just assume and cut. Now, when I cut the geometry, what I do always, I replace that by forces and moments. So what we can do, usually, technically, we should have a force in that direction to support what? The one in red, that direction. But because, as we say, this force doesn't exist, this force doesn't exist as well because they are equal to 0. There is no values for them. So now which force I have? I have a shear force, which is of the cut in that direction. I will just highlight it so you can see it, guys. And I will use a color so it can be very clear. So I will use the green. All right. So that's the shear force, which I will call it V. Do you remember we talk about the shear force V several times when we're trying to find the bending moment diagram? Now, also, when I cut the object, I should create another thing, which is a moment. And that moment, I will assume it to be going in that direction. So if it's, let me rotate it. That's moment, it should be in that direction. This is technically the cut. Again, I'll explain this again. This is an imaginary cut, it's not a real cut. We cut it just to understand what's exactly happening at point C. And therefore, when I cut, I replace whatever I have at that point with a shear force called V and a moment M. So I need to type that moment is called M, because that's the question we're asking you, is to find M and the shear force. If you have any questions here, guys, please ask me. Why it's going anti-clockwise? All right, good question. Because if you look to the direction of the balance, how can I explain it in an easy way? So basically, it's kind of against to whatever point A is trying to do, and also against of the direction of the UDL. It's just always when you have these arrows, try to achieve equilibrium as much as you can. Always when you try to put these arrows, try to imagine, hey, I need to balance it. So if a force going in that direction, I need to have something opposite to it. But worst case scenario, if you didn't assume it right, the negative answer should correct you to the right answer. And that's why we say when you get a negative means always that it should be fine. You should get the correct answer for it. All right. So that's hopefully will answer the question for you. Now, again, this question, we are not sketching shear force on bending moment diagram. He doesn't want you to do that. He wants you to find it. Yes, you can always assume it anti-clockwise as a good start. All right. So now for that diagram, what's happening in U now? The UDL, it's not anymore covered with about 3 meters. The UDL now, if you look carefully, it's became what? 9 times 1.5 or what? Can you tell me? What's the UDL now? It used to be times 3. Now it's 1.5, and we put it in the middle because now the UDL, since we cut, we kind of lost a 1.5 meters from that UDL, which is under the M, under this box when I did that imaginary cut. All right? Yes, exactly. So it's about 0.75 from each side. Well done. All right. So now this is the free body diagram. It's done. I don't need this. This here is just so I will show it in this way. When you resketch, please, again, because of my size of, I'm using the PowerPoint slides, I really want you to draw this on your paper again. Don't do like I'm doing in your test. In your test, you need really to draw your free body diagram. Who's saying how we can take 9? 9 because it's always UDL is giving to us as 9 value. That's why we need to use it always 9. So what's it telling us? Every 1 meter is weighted as 9 kilonewtons. That's technically the meaning of it. So when you have a 1.5, so we need to multiply how much will be. So you have 1 meter is 9 kilonewtons, and half meters will be half of that 9 kilonewtons. So that's why you get the answer for it. Okay. Now, we start again, summation of forces in the vertical direction. Very easy to find what's the value of V. So summation of forces in the vertical direction, I will assume going upwards is the positive direction. Just I will assume it again. It's an assumption. It's nothing really will try to confuse at this stage. Okay, what do we have? Let's write down. We have what we found. Do you remember the value for A? Yes, we do. The support reaction at A we found is equal to 15.75. I'm just highlighting it. Is going upwards? Yes, therefore it's positive. Minus what? I have the 12 kilonewtons going downwards. That's why I put minus. Minus what again? I have the UDL, which is 9 times 1.5. And why is negative? Because the arrow is going downwards. That's arrow. So if I highlight it to make it a bit slightly bigger in the size so you can see it better, it's going downwards. Against all of that, what's going downwards as well, based on my assumption, it's the value of my V. So I'll put minus V. Because look carefully, V is assumed the green color. I assumed it, by the way, is going downwards, equals to 0. This, you arrange it again, you'll find, I'll give you time to find the value for V. It's a good practice for you guys. So maybe, I don't know, 20 seconds to find the value for V. Please start posting the answer privately. Always use the private mode when you're chatting, so we don't interfere with the other guys. I start getting some answers. The first answer was from Michael. Are you sure from the direction that is it is positive or negative? Sagar, I think you're correct. The other guys, you need to check. Parpinder and Michael, check the sign. Matthew, you're correct. By the way, I was looking for, what's his name? Did Ronil join the class? Ronil joined the class. Well done, Ronil. And who else joined just recently? I have someone else joined just recently. It's fine, Ronil. It's all good. If anyone just joins recently in the last few seconds, just saying, Hofei, your answer is correct. Okay, Ninant left and joined. All good? Is the sounds working now for you, Ninant? Is all good? Michael, just repost your answer because I think I commented on it. Michael is saying, okay, you're using as a compressive. I will check now the answer. So let's check the answer now together so we can see what we're doing. The answer for this question will be what? What do you think? We need to make some minus 9.75 kilonewtons. Now, here is a good point. Guys, compressive or tensile test is only when it's perpendicular on the cross-sectional area. This shear force, it's not really perpendicular. If you look into the beam, this is not applied at the cross-sectional of the area. So we don't write here it's a compressive. You write compressive and tensile in the truss question. The question which involve, if you remember, when it's only concurrent forces, that's when you start writing compressive. You remember when you use the joints and or the pin and we work on it. When it's at a point and is applied on that cross-sectional area, then we call it's compressive. Now for me, it looks like it's very difficult to judge it because it could be tension or compressive. It's difficult to judge it from this direction. No, in the beams, you don't need to use compressive on tensile, only in truss analysis. And plus, they will tell you when you use it, guys. They will tell you and state if the beam is under compressive or tensile status. Always they will ask you to state that. All right, very good. Many of you managed to get the answer correctly. And the guys who got the positive answer, please always check your signs. Now, second step, we need to take the moment because we need to find the moment. Because the question asks us to find the shear force at point C and the moment at point C. So I change from A, I put C equals to 0. So very easy to work on this moment, but I want you guys to pay attention because some stuff did happen and change the story. Now, I'll assume it again, the positive direction is counterclockwise. Today, I always, like maybe in the last 3 weeks, I always assume it clockwise. Today, I decided to use counterclockwise just to show you the difference and how it works when we solve it in different direction, just for a try. All right, so for this question, the counterclockwise, a moment around C. Remember, when we say around C, this moment will not be canceled. So please be aware, the moment under moments, it will be added. The only thing will be canceled at that point is the effects of the shear force V will be going away. So let's start writing the equation. What do we have? So we have A. A will be rotating what? Clockwise, so will be minus. So let's put a new line. So minus 15.75, which is the value for A, times the distance. 1.5 plus 1.5, that's 3 meters, plus 1.5, that's 4.5 meters. All right, we work from here. Now 12, we'll try to rotate the 12 in which direction? Counterclockwise. Perfect. Plus 12 times. The distance is 1.5 plus 1.5 is 3 meters. Awesome. Plus, what do you have? The UDL. So it's positive. UDL would try to rotate me in that direction. So what would be the UDL? The UDL, it's 9 kilonewtons per meter. So 9 times 3, that's kind of a force, multiplied by what? The distance, which what we say, half of that. So half the 1.5 is 0.75 equals to what? I missed something. Don't miss something. Which direction my M at C will be rotating here? It's counterclockwise, so plus M equals to 0. Everything I assume, I should stick with it. I cannot change things based on I like it or not. Okay, that's a very, very important rule. And you always need to work it out. So someone is telling me, yes, you're right. Sagar, perfect. It's 9 times 1.5. I missed that. I even wrote it here, but for some reason I took it. Thanks. Thanks, Sagar. Thanks for correcting me. It's 9 times 1.5 times 0.75. I wrote it, and that's this things it's really sometimes get you confused. So please always revise and see the answer for it. Okay. Now after we did that, rearrange. You need to find the value for M. I'll give you time to type and find the value for M. And then post it privately chat. Any news? I got the first answer from Buddy. Well done. Good answer. From Ninat, sorry. Oh, Buddy, the first one. Good. Ninat, good. Parpinder, good. Matthew, well done. Sagar, good. Well done, guys. All right. So the answer is 24.75. Don't forget the units, guys. Kilonewtons times meters. Please, I will be very, very tough with marking your final answer. If missing units, you write it. You don't need to write tons. It's not tons. The right unit is kilonewtons times meters. Is a force times distance. Tons is a weight or kgs or mass. So completely different definition. No, it's not tons because that's mass. We're talking about a force multiplied by distance. All right, so by this, successfully, you managed to finish the question itself. So I'll repeat this step, the last step. Just to remind you, the question wants you to determine the normal force, shear force, and moment at point C. So step one, what we did, we went through the question and we draw the free body diagram. Again, I will explain this really very important. You technically, when you have a hinge, we always have an X components in that direction. But because there is no other forces in the X direction, therefore this X. So what I say, FH here is equal 0, no forces in the H direction, which represent the horizontal. So I'm acknowledging the information that, hey, I'm aware this is a hinge, but is not effective because there is nothing is moving the beam. Similar to the whiteboard we had in the class. It's when it's fixed on the floor, it's always showing you that it's not moving. So there is no forces in the X or direction. But when I push with a force in the X direction, definitely the whiteboard will start moving. So that's a difference. So you need to acknowledge it, definitely, or you just need to sketch it and write this force is equal to 0. So you can put something very small here. It's not much. AX is equal to 0. So something very, very easy to acknowledge that you understand there is no force there. And to be honest with you, in many, many cases, if you find the answer and you find everything perfect and you forget to put this one, I will not be tough with you about this because I know this didn't impact your solution. All right? Now, the second part of this question is to take a section. So a section, what I did, I just hide the information. So what I kept one of the ends A till the point C wants me to go and find information about point C. So we want to find the shear force at point C and the moment about point C. Therefore, because easy for me, for you can redraw again till that point. So for you on the paper, you draw everything till that point. So instead of the 6 meters, you draw it till 4.5 meters. And then you put the moments and you put the shear force V and the moment. And after that, okay, let's see, I will go through this and then I will try to answer your chat questions. After that, we did distributed the UDL will be 9 times 1.5 and will be in the center of that distance, which being 0.75. And then we wrote the summation forces in the vertical direction, summation forces summation forces for the moment about point C, and then we find the values. Now let's read your comments. So we start with the first one. If it don't try the FH is equal to 0, just discard this, it's okay. I mean, if your answer, all of it is okay, I don't mind that, all right? But if something wrong, then I mean, you don't understand the principles of this question. Now, another question. You covered from C to B and calculated from A to C. Can I do it in the opposite? Very good question. Let's do it. I like Min question. Really, really good. We can do it, Min. It's nothing will be good. So after I read the other questions, we can do the other side and we can compare. What if we took the side that is covered? Okay, another question coming about that. When you make the imaginary cat, could you cover the other side? Good. So more questions coming from other students about the other side. I like it. Okay. So that's a good thing. So a couple of you ask why we don't cover the other side. So since we did this, what I will do, I will copy this slide in another slide and then bring it. Oh, sorry. Control C, Control V. And then we can play with the second slide and let's cover it. So technically, the rest of the group saying, hey, let's cover it from this to this side. That's technically what they're saying. Let's delete this information. Actually, we don't even need to delete it. It's just we need to rotate it. Yeah. And that UDL will be here. And we don't need this. We can hide everything. And we don't need this value. So we put here. So it'll be 9 times, what's the distance till 1.5, correct? Do you remember what's the value for B? I think we found it here. So I need to copy that number. I would just highlight it. So at least we remember this value. All right. B is equal to 23.25 kilonewtons. And the UDL is 9 kilonewtons. And this is the moment. All right. Now, if you look, let's keep the main equation, but I will delete the answers and we see what we're getting. So we can justify the questions. All right, so summation of forces in the direction going upwards. What do you have? This is very, very easy. So you have 23.2. So what we're saying, going upwards is positive. So 23.25 is positive. Minus 9 times 1.5 minus what? V. Can you find the value for V? What do you think? Logically, you can see it. So can you try it? I'll bring my calculator and see it. So 23 so the answer, okay, someone, okay, Sagar, can you check the units for your answer? So some of you getting negative, some of you getting positive. Why are you getting negative, guys? If you look carefully, what you will have in the equation will be V is equals to what? 23.25 minus 9 times 1.5. So I don't know why you guys getting negative. So it should be what, guys? Because if you look carefully, it should be the answer 9.75 kilonewton. Go and check the previous solution. Is this what we got in the last solution? My answer is positive. Of course, it's positive because you have the big number that minus the negative number. So you can take the V outside and then you keep that one. So your answer is correct, Sagar. Now, why? Why this happened? So technically, what did happen in this question? The last one, we got it is negative. This one, we got it as positive. This is really, really, really very good question because I'll explain to you very soon when you finish. Actually, I will find it even in your lecture notes. So I will try to go and to go to the topic of beams because I'm quite sure it's described in your lecture notes some stage. But again, try to do the same thing and find the moment and tell me if we get different moments as well. So continue with it and try to find the moment. Do you find the moment values, guys? So maybe we need to write it. Shear force. I'm waiting for the moment values, guys. Well done, Sagar. Okay, the rest, Min, you getting it negative. Depends on the direction you're assuming the moment. So shear force imaginary cut. Okay. Right. Another one, Zen. Well done, Zen. Good. Okay. Well done. All of you got it. So the answer for your question, guys, very basic, very easy. The answer, it doesn't matter. Now, the only difference, you start experiencing that you're getting different answers. I'm now explaining to you guys very easy. So this, I'm opening a new page. So to answer you again, is no such difference, but that's what we want to, I will show you why we're getting different answers. So let's say this is a complete beam, the one we were studying before. And then suddenly we can divide this beam to two parts when we exactly cut that beam in two parts, right? So the first beam, it's case one. Let's call it here case one. So now, if I hide the beam from one side, what will happen when you break the beam at that point? So let's say there is a breakdown at that point in the center, and the center is here technically. I'll make it as a center line. So what will happen to the beam? One will go down and one will go up. That's technically, that's how it's happened, the friction. Try it with a pencil. If you have a pencil and you don't want to use it, so when you break it, you see a 1 edge. So what will represent for you? There are shear forces. What will be? In one side, they will be going upwards, and in the other side will be going downwards. And that depends on the direction you're cutting that beam. Therefore, could be you pushed it from below or from above. And that's why we are getting, guys, different signs, but still you get the same answer. So this is kind of an explanation for the shear force, how it works and how it operates. So this value of the force, we call it V. So you get it, should be the same value, but different direction and acting on the way you call it. So if one end's called A and the other end, it's called B. So here's the question. If I work on this and try to hide one side, what will happen? I will see only that side. Now, if I try to hide that side, well, I will see that side. That's exactly what's happening with you guys. So you start getting the same answer, but the magnitude should be the same. So magnitude is same, but different direction. Perfect. Yes, Sagar, it's correct. But do you see how I'm doing it? So when I'm hiding that side, what I'm getting actually, I'm getting that side of my view. But when I'm cutting it from that side, I will get what? I will get the other side of the view. And that's exactly what's happening to the cut. It depends which direction you're taking it. And that's why I would say this is really very important for you guys in your test. I will assume not all of you will assume the same directions. Not all of you will take the moment as clockwise or counterclockwise. You have two options, and some of you would choose that, and others would choose the other one. And not all of you will take my assumptions. Like for any questions here, and that's something is unique and beautiful about mechanics. It's all of you may start different assumptions, but at the end of the day, we need to end up with the same answer, with the same value, because we are looking for magnitudes. So when we say there is a support reaction, someone will assume it in that way and others will assume it, for example, in that way. It doesn't mean any one of them was wrong when started solving this question, but technically the answers were correct for you. So you see, each one with different assumptions starting to solve the question at point A, but at the end, your solution will correct for you. So again, when you cut it from one end, you should get that exactly the scenario for it, or when you cut it from the other end, you should get it in that scenario. And that's exactly the explanation why you guys taking or you're getting a negative answer opposite to, because it's opposite to the other direction. This shear force kind of applying. And if you have a pen and you really want to test this how it works, and you have a pencil and you don't really want it, what you see that your finger from the top is pushing down and your finger from below is pushing up. And those different shear forces trying one to go upwards and the other one downwards, and they will have the same value or magnitude but opposite directions to create that shear force. Shear force, I will call it the cut force, which is trying to cut the beam at certain points. Is it clear now? Hopefully now it's a good question you ask, guys. And now the answer, to go back to the answer, you should guys go and get the same values for the moment and same values for this. So that will be, if we write the equation for that one, we should get clarification about that. So now let's try. So we solve it for the shear force. Now let's do it for the moment. I want to finish that. I want to leave it in this stage. So for the moment, what do you have? If we assume counterclockwise, so it will be B times 1.5 meters. And then what do you have? You have the cantilever minus, will be rotating clockwise. So it will be minus 9 times the value is 1.5, which is the load, times the distance, 0.75. And also you will have plus or minus here in this case, because it's my moment here. If you look carefully here, I assumed it clockwise and my assumption. So minus m is equal to 0. And then if you arrange that, what should be your answer for the moment in this case? Can you write me the answer, please? I'll get it for some of you. Yeah, 24.75. 24.75. Now, why I'm getting it positive, if you look carefully, because I changed my direction. Remember, if you go back to the video, the other one, I rotated this M, if you remember. So when you go back to the recording video, you see I changed the direction of it. So that's technically, I changed everything about this question. And that's the things I'm trying to show you here today. Yes, different solutions, but at the end, we got the same answer, which we are interested in. So that's really, really very good question. And I hope in this, we clarify this question. Now, the good news, we have about 23 people attending, and if without me, it will be 22. I just want to make sure the guys who are here, I'm just worried about to make sure to take you guys your attendance. So if I call your name, please just type on the private to make sure you're there. If I don't call your name, it means your attendance was there. I ticked it already. So Ibrahim, if you're here, please send me a private message on the chat. Asim, if you're here, send me a private message. Caleb, the same thing, send me a private message or chat. Wesley, please, the same thing. Wesley, please send me the private message or chat. And Oliver. Other than that, should be all good. Okay, I need to leave for work soon. Or we done for the day. So I think that's very nice. And this is, I think, I'll try to publish this video. And really, I wish you the best of luck. What I want you to do, guys, maybe we have about 10 minutes since we've done this question. Maybe if you try to sketch the shear force and bending moment diagram for this question, but because of the time I'm looking at, it may take longer than that. So maybe we can do the shear force first. So if you guys try to do the shear force diagram for this question, would be very awesome. So that's the question. Do you remember the moment, the bending moment, I took it in that direction? And then when I tried to solve it, I took it in that direction. That's why we're getting the positive answer, because I already changed its direction. So it was a trick from me to just a bit to see how you find it. All right. So if you want to sketch the shear force and bending moment diagram, Michael, it's recorded in video. You can watch it anytime and will repeat itself as much as you want. All right, that's why we're recording it, Michael. All right, so now if we try to sketch the shear force bending or shear force diagram, sorry, it's very good to show you guys how can we do it. So I will remove those equations to have enough space so I can draw the shear force diagram, and will be very easy for you guys. And as well, I may ask you questions about the values for A and B because I need them to help us to determine the shear force bending diagram. All right. So technically, when you get this one, what I recommend for you all the time, guys, and please remember this in your tests, always just project the lines wherever you think there is a possibility of force, and try to use this as a reference point for you. I mean, you can make it disconnected line or connected line. Please remember to bring with you calculators and ruler for you, or something to make your drawing tidy and clear so you don't confuse yourself. Hopefully this will help us to find a very nice shear force diagram. All right, so guys, can you remember me what's the value for the force at A? Because I technically remove the answers from it, so try to find it. Okay, I'll write it down. I think I let me remember if you can remind me. A was 15.75 kilonewtons, and if you can remind me about the value for force B, it was 23.25 kilonewtons, and the directions, both of them going upwards. So it's really good. Thanks a lot for reminding me, guys. It's really good. That's one of the helpful things. All right. Now, what we learned, shear force diagram. So always we start with one of the free ends. I prefer to start from the left, except from the cantilever. What we say, you start from the free end. Okay, so that's something really very helpful for you guys. So I'm going upwards with a value. Let's say it's 15, but before that, I need just to highlight it to make it looks obvious and you can see through. I change the color to make it red. Okay, so this one, I'll write information here. Follow me exactly like the same thing. Shear force, I just need to write SF, kilonewtons mean the units, so I don't need to repeat every time I write a number here, and then I enter the value. So let's say the value here is 15.75 kilonewtons. All right. Now, if you look carefully along this, there is no effect of any force. So I move from that line. Oh, I deleted. I'll delete this. I got really not really cool. So I move exactly. When you click Shift on this line, it gets you that's a very nice horizontal line. Again, I will make it really darker in red color so you can see it. Okay, now 15.75 minus 12. Can you get me that answer, please, so to help me? So that will be something maybe till point here, something like in between. I appreciate you guys helping me. It's really cool. So the answer, let me check. It's 3.75. Perfect. So I would type here 3.75. Perfect. You guys are doing well then. I think you're ready. Now, what we do is the next step. It's again, this will continue. Since I have this line, let me be more creative. I'll use this line, and that will continue to here. Now, here is the things what we learned before. So now I have what I have. Please ignore this wrong dimension. This is what's for the previous section, and ignore this one. We have only here. This is not a shear force. what we have here, we have only the UDL. So the value for this one is 9 times 3 meters. All right, which is equal to, you find the value. So 9 times 3, I don't have the calculators with you guys. Where's my calculator? I can't find my calculator. Help me, help me. 27, perfect. Thank you. Now, here, this is the UDL, which is at the center here. But please, at the same time, remember that this UDL, it's completely different story. So it's going downwards. So how can I go and do that? What do you have? Look carefully here, guys. You have 3.7 minus 27. What's the remaining of that, please? So I'll write it down so you can write me the answer to help me. This will be 27, it's from the UDL, minus 3.75 is equal to minus 23.25. Thanks a lot. That's number. So see now where should be my line is taking me. Control C, Control V. I will take just this line. Because it's UDL, it should go somewhere like this. And then I put a value of here minus 23.25. And look carefully, what do I have? I have my support reaction, which will close to me the shear force diagram. So here is minus 23.25, and then the support reaction 23.5, and that's what closes it. That's exactly how it looks like, the shear force diagram. It's very easy, very good, and not that difficult. Any issues with that shear force diagram? I think it's straightforward. Now, I'll give you time, and you will help me as well, because I need kind of a space to sketch the bending moment diagram. I may do it on top of it with different color. See, what we can do, it's very interesting here for bending moment diagrams. I'll show you techniques we can use. We can use print screen. We go to Paint, and thank you for Paint to not removing this software from our PCs, because otherwise I will not be able to do this application without Paint. So always thanks for Paint. We need to thank them for their help and support. And then I go to a new slide, and that slide, I'll bring it here, and then I can rescale it. I don't really need this. And say thank you. Rescale it to be in that size, so it will give me enough space. That's better, right? This is really better solution. Now, this will help me a bit of space to continue and find the bending moment diagram. So hopefully in the future, maybe you'll be more faster than me in using PowerPoints and how can effectively use it. And especially when you have presentations or you want to draw your lab reports or assignments, so I'll help you in doing these things. All right, now, again, what we say to avoid us from repeating units, we just write here bending moments, BM, and units is kilonewtons meters. Very easy. This will avoid me to have any issues. Now look carefully here, what we're working as areas. So the first thing we start is by area. So what area we seeing here? The first area, it's positive, right? So I'll bring here area 1, call it, equals to what? 15.75 times the distance, which is 1.5 meters. Please, guys, I don't have calculators. I really appreciate your help. My calculator is not, I can't find it. 23.625. Thanks a lot. I will type the units, kilonewtons meters, to avoid any issues. So again, what we learned from our course, If it's rectangular shape, always we move as a slope. So technically, it's positive. I'm going in that direction, positive, because it's positive area, positive number I'm getting. And then I will highlight that number to make it darker. So that's line. And I'll choose, for example, green. I like the green. Looks better. All right. Now, I also have another area, which is the tiny one. I will call it area 2. Area 2 is equal to what? 3.75 times the distance, 1.5 meters. So 3.75 is the height, the distance is 1.5, equals, can you find me the answer? Is 5.625. Very well, very well. Now, plus what? The 23.625. The last area will be equals to 29.25 kilonewtons meters. Well done. So I will continue from that, but should be going reasonably there. Now, because I forgot to put my values, I need always to satisfy my values and put them there. So the first one was 23.625. I don't need to put the units because I have the units already set up. And then I need to make it look logically that it did go by about 5.625, so 29.25. And now what's happening here? See, here is what we learned in the past. Now, what we need to do is to find the X value, something we done last week. So at this point, I need to find the X. That's tiny X is something very, very, very important, and we need to determine it. So let's say it's by similar triangulars, I can find it. So if this one X, this distance will be, as we say, very easy. The remaining of that distance, oopsie, I should use the text. So it would be 3 minus X. It's zoomed to our top left screen. Oh, why? Maybe we have been here for a long time. Maybe now? Is it better? Can't see your screen. Done. Okay, all of you can see the screen. Perfect. Okay, so if that is 3x, and this one, the tiny one, is x. Now I need to find the value for x. So what we say, we type an equation to show us how to determine the value for x. So to do that is very, very easy job, is by that's distance divided, kind of using the trigonometry things. So I use the equations editors to help me to solve this together. So x divided by that's 3.75 equals to what? To, I will put the other part, what's opposite to that is 3 minus x divided by the 23.25. Now I bring this from that side. So rearrange this, guys. I want you, because since you have your calculators, can you find me the value of x? It's okay if you don't draw it to scale. So x is equal 0.4167. Please check that number. I'll put question mark. Check that number, because I haven't solved this question before, so that's why I'm relying completely on you guys. So if the rest can confirm that number, would be so awesome. And then I will start with area 3. I will wait for you guys. Yes, okay, so confirming. Now, area 3 is the small tiny one, which is 0.5, half of the base, times, what's the base? We just found it, 0.4167 times what? Times the height, which is 3.75. So can you please find me the answer for this one, for area 3? So half the base times the height. The base, which we found, is the value of x. Good. So it's 0.78. 0.781 kilonewtons. Now, is this area negative or positive? And I'll explain to you. At the same time, if we found area 4, which is half the base, now the base, remember what's the base, is 3 minus 0.4167, the value you're giving to me, times the height, which is minus 23.25. So I should get a negative area, the last one. So if you can find me area 4. Good. Now, see the magic. You get me area 4 minus 30.031 kilonewtons meters. Now, 0.781 plus the last area, which was 29.25. What's is equal to this? What's equal to this? So can you tell me the answer for this? It's equal to what? So 0.78 plus 29.25. What's the answer for this one? Should be a negative. 30.031. See the magic? Do you see what we're doing? And that's mean. So I will continue with the green line to show you what exactly is happening. So that line will come here from that point. We'll go very slightly to go and stop. Again, it's a straight line. I will type that area, which is, let's call that area. What's the value for it? Is 30.031. And then I should get another one to close for me the bending moment diagram. So I bring this one here. I just rotate that to that point. And that's what is the last area which to close the bending moment, because this one minus the value. So to check what we do 30.031 minus 30.031 is equal to 0. That's where it's taking me to the bending moment diagram. Now, good question. What I done? Again, I done mistakes. This should be parabola. You're right. So that's correct. So what I do, I need to find a parabola. That will be the most difficult things I need to do. It's very difficult to do parabola in the software. It's not the best things. I'll try to avoid it. Yeah, no, it doesn't work with this one. I'll try to use different techniques. On these lines, I may use the pen. It should goes like that. And the last one, it should goes kind of like this. Yeah, you're right. But the problem I struggle with is getting this parabola. So I should get something. Yeah, it should get you something really parabola, but because of the software, it's closing. Who's saying it's not closing? Why shouldn't we have two parabolas? Yes, we should have two parabolas. So one is going in that direction and one is going in that direction. Two different triangles, one positive and one another negative. Should the vertex be at x with 1.5? Not the middle of UDL. Which one? No, we didn't use the middle. I used the all 3 meters, and x we arranged the equation. So we find that tiny x is 0.4167 and this one 36. Total 3 triangles. Not that we don't have 3 triangles, guys. We have 2. The small one, this one, I will highlight it for you guys. I maybe zoom to it. So I have this triangle, the small one, and the big one. Now, because I use the complete area, so what I use the total height, and this all of it's 3 minus x. So that's why I use the 3 minus x. So if you look at there, I use only 2 triangulars. I know what you're meaning, but I moved out of it. So technically, you're really right. This should go, actually, you're really right. And this should stop here. And this one is a bit slightly difficult to do it with this one. I think I'm managing it. Hold on. I think I'm managing it. Yeah. Is it better now? Looks better. Yeah, it looks better now. It should be something like that. Yeah. It's just the word, what's they call it, the software is really not very supportive to this kind of things. So let me delete the green one. Now I come to this tiny one and I make it really looks, yeah. So it should be something like that. That's the precise for it. A3, how got the 0.5? 0.5 is the half of the base. So that's half of the base. It's always what we use it for triangular. That's why we write 0.5. So again, thank you for Thais and Matthew. And that's what I was meaning. So thanks. Yeah. So now it's corrected, looks better. And that's one of the things always, guys, you need to remember it in your test. When it's a triangular or UDL, always on the bending moment diagram, it should be as a curve, parabolic. Otherwise, you may lose marks like I'm doing it now for myself. And because of many things going around. So that's how you do it. I mean, in your test, I don't really predict you to have a proper parabolic, but as soon as you show it a bit of curvy, that will be more than acceptable. All right, so that's today the answer of the question. Do you have any questions?